Yep. Okay. So this is it. This is the last one. And it is a linear regression t-test, okay? So the linear regression is a model that estimates the relationship between a dependent variable and an independent variable. And both variables are quantitative. So you may be wondering, why in the world are you teaching this with chi-squared? Well, chi-squared is qualitative, right? And so sometimes we have one sample and we're looking at two qualitative variables, which was chi-squared for association or independence. This one is linear regression, but sometimes people say, is there an association between the two variables? So you just have to pay attention. They both have to be quantitative, okay? Quantitative. So the first one, which we call the independent variable, is sometimes referred to as the explanatory variable, and that is the variable that we manipulate or observe changes in. Okay? So that's the variable. Maybe, for instance, you're interested in caffeine and energy levels. So you're going to change caffeine, the amount of caffeine, and then observe the change in a person's energy level. Okay? So Ms. Whitaker last year would have said, we implement some kind of change. We implement something to change. Okay? And then the next one is called the dependent variable or the response variable. And that is what changes as a result. So for the response variable, a way you can think of that is it's the outcome. Okay? So two quantitative variables, we're looking to see, is there an association between them? We have the explanatory variable, which is something we manipulate or we observe a change in, and then the response variable, which is the outcome. Okay? All right. The reason why I included independent variable and dependent variable is that's how you would have learned it in like pre-algebra and algebra 1. The independent variable is your x, the dependent variable is your y. Okay? So we're going to run hypothesis tests for linear regression for slope. So we focus on the slope of the regression equation, which is y equals a plus bx. So I highlighted b because that's what we're looking for. That is your slope. What is the other variable? A, because that's going to become a number. A will become a number and b will become a number. Last year in pre-calc, I taught you y equals mx plus b. So remember, whatever's with the x is your slope, and whatever's the number at the end is your y-intercept. Good job, y-intercept. Same thing with this, okay? So that is still going to be the y-intercept. Whatever's with the variable x is still going to be your slope, okay? So how do we perform the test? Well, first you write your hypotheses. The first one is always the same, okay, everybody? So that's kind of beautiful with this one. The null hypothesis is always that beta, so I use b for slope here. B is going to be my statistic, okay? So beta is your parameter of interest. Which will be your population slope, okay? So population slope. So if there's no association, which is your null, that's going to be beta equals 0, which means no association. Your null is always going to be that there's no association, okay? Now, your alternate depends on the scatter plot and what you think for the data, okay? If I look at a scatter plot and it looks like as x increases, y is also increasing, then I'm going to say beta is greater than 0, which means I think there's a positive association between the two. okay? But what if I look at it and it looks like as X increases, Y is decreasing? Then I might make my alternate beta is less than 0, which means a negative association.
I remember this now. And then the one where it's not equal, that's when it's like dots all over the place.
Yes, good. So when there's dots all over the place and I'm like, oh, I don't see a positive, I don't see a negative. So I'm just going to say, okay, beta does not equal 0, which means I'm just looking for an association. Okay? The next thing you do is check your conditions, which sometimes is also referred to as assumptions or criteria. Okay? Miss Whitaker last year had you check 2 and 3, but I've read some textbooks and online resources this year that said to also include random. I'm not going to be as worried about that, though. If we don't get that it's random, we'll still move forward and run the test. But I did see that in some, so I thought, well, with most of them, we do want a random sample, so I'm going to include that this year, okay? So first, check for random. Next, check for linear, okay? So the way that you check for linear is you look at, it deleted a lot of it. Okay. You look at the scatter plot, okay? And you look to see, does it look like it's linear? All right. Then you check to make sure the residual plot is scattered. So last year she showed you how to find the residual plot, but I did put the in calculator instructions right here because it's hard to remember stuff from a year ago. You know what I mean? And you don't do this one all the time.
I would have never remembered that.
Yeah. Well, I typed it this year because I was like, we cannot remember. I mean, me too, because I don't run these tests very often. The most common are proportions and means, but sometimes students want to see if there's an association between two. So the first thing you do, okay, you put your X's in L1, you put your Y's in L2. Then you go to Stat Calc and you choose the linear regression test, okay? Then you go to Stat Edit and you're going to highlight L3 by arrowing over and up to it, okay? And then you hit second stat and you go to option 7, which is residuals. But I will tell you, on one of the calculators I've been using, it's actually option 8. I don't have any idea why, okay? So just look for residuals. Then go down and highlight that option and click enter. Then it's going to say above L3, it'll say residuals, and just press enter again. And it'll put the residuals in your L3 column. Then you go to second Y equals, which is the top left button on your calculator. Go to stat plot, and then change your Y's from L2 to L3, which is your residuals. And then you just do zoom 9. Zoom 9 is what we use for scatter plots and residual plots, okay? And we'll do this in a second. We'll run the test. So calculator instructions to run the actual test and not just be checking the residuals. You actually run the test. You're going to put your X's in L1, your Y's in L2, and then you're going to go to Stat Test, and you're going to go down to F, which is a Lin Reg T-test. Okay? So right there, that tells you what your test statistic is. Remember how I told you to look for that? What's your test statistic on this one? T. Good. So you're going to record the p-value and the t-value because t is your test statistic. Then you link your p-value to your alpha level to write your conclusion. And we reject or fail to reject the null. So then we state if we do or do not have evidence for the alternate. Okay? So example 1, can a low barometer reading be used to predict the maximum wind speed of an approaching tropical cyclone? For a random sample of tropical cyclones, let X be the lowest pressure in millibars as the cyclone approaches, and let Y be the maximum wind speed in miles per hour of the cyclone. Consider the following random sample. So this is a really small sample, okay? But we can still use it. This is how you insert a scatter plot on Excel. I think I showed it to you when I was teaching you all that at the beginning of the semester, instead of choosing a box plot or instead of choosing a bar graph. The main thing is insert all your data values and then make sure you highlight the data values and the headings. That helps it so you can figure out which one's your X and Y. And then you just go to insert, click on your scatter, then you change your title, and then you can click on the data points and customize it just like we did all the other graphs, okay? So the descriptive statistics you report for a scatter plot, Miss Whitaker taught you the acronym LIDS, okay? L-I-D and S. So what does the L stand for? Well, it's actually one of our conditions we have to check. We have to look to see, is it linear? Okay. The next one, the I, stands for influential points. And the way that I think about influential points is I look to see, does there appear to be any outliers? Influential points are kind of like outliers. They're going to pull the line that fits the data away from the other points. So they would influence it, okay? They'll pull it one direction or the other. And then if you removed it, that line would fit your data better, okay? The next one is direction. So direction means read the graph from left to right. If it's going up, we would say it's positive. If it's going down from left to right, we say it's negative. And then the last one stands for strength. And the way that you determine the strength is the R value. Now, the R value is called the correlation coefficient. So, to get your calculator to tell you the correlation coefficient, I'm going to write the instructions right over here. You're going to hit second 0. And if you read what that says on your calculator, above the 0, which is why you hit second first, it says catalog. That literally catalogs everything your calculator will do, okay? And then you're going to arrow down until you see diagnostic. I can't spell this morning, I apologize. Diagnostic on, and you press enter. And then it moves it to your home screen and it'll say diagnostic on, and then you press enter again. Okay, so you're going to highlight diagnostic on, hit enter. It moves it to the home screen. You're going to hit enter again. And then when you run these tests, it's going to give you your R value. Okay, your R value tells you how strong is the correlation between the X and the Y. Okay, it's the strength of the relationship between the X and the Y. Questions for me? Any questions? Not yet? All right, so we're going to graph. I could use Excel to do this, but it's a really small, there's not very many points at all, okay? So I'm going to graph the tropical cyclones data. So I'm going to write tropical cyclones. And which one was the X? It said let X be the lowest pressure in millibars. So this is going to be the pressure in millibars. And then the Y, it said let Y be the maximum wind speed. So this is going to be the wind speed in miles per hour. Okay? So your X and your Y doesn't have to go by the same increments. Last year I had you always put them in the same, you know what I'm saying? If you go by 2's on the X's, you go by 2's on the Y. But that's so that you didn't distort quadratics and polynomials, okay? This year you do not have to have the same on the X and the Y. So if you look, your X's are 1,500 934, 975, 992, 935, 985, 932. So I broke it right here, and I started with 930 because my first data value was 932. But I need to go up all the way to 1,000. So I went by tens, okay? That's just a choice I made. So I made this 940, 950, 960, 970, 980, 990, 1,000, and 1,010. So then when I looked at the wind speed, my wind speeds were 40, 100, 65, 145, 80, and 150. So the lowest data value was 40, and I needed to go up to 150. So I decided to break this side as well and start at 40. And then I decided to go by 20s on this one to be able to make sure I can fit everything. So 40, 60, 80, 100, 120, 140, 160, 180, 200. I think the highest was what? 145. No, 150. 150. So I definitely went up high enough. And then you just plot your points, okay? So the first point is 1,004. So I'm going to go all the way out here past 1,000 and then up to 40. The next point was 975, which would be halfway between 970 and 980. And then 100. So I'm going to go right in the middle, right there, on 100. Then 992, 65. So it's going to be, halfway would be 70. So halfway between that. So about right there. And then 935, which is halfway here, to 145. 985, which is halfway, to 80. And 932 to 150. So I'm going to write lids and then I'll let you go. We're going to analyze our descriptive statistic. Do you remember what the L stands for? Is it linear? Does that appear to be linear? Yes. Okay, influential points is the next one. Let me just write it. We'll answer it next class. D stands for direction, and S stands for strength. Now, we'll actually have to leave this blank until we run the test down below, and then we'll come back up and answer that one. Okay? Any questions for me so far? No?